Welcome to Unstoppable Programmers. Today, we delve into an important sorting algorithm known as bubble sort. Whether you're a developer or just curious about algorithms, this video is for you. So let's get started. Bubble sort, as the name implies, involves a process that is akin to bubbles rising to the surface of a liquid. But in this case, the bubbles are the numbers in an array and the surface is the end of the array. Now, imagine you have an array of numbers that you need to sort. Bubble sort is a simple comparison-based algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This process continues until the array is sorted, and just like bubbles in a fizzy drink, the largest number bubbles up to the end of the array. We start with the first pass. We compare the first two elements, and if needed, we swap them. We repeat this process for the entire array, comparing each pair of adjacent elements and swapping them if they're in the wrong order. Watch how the largest number, let's say 7, bubbles up to the end of the array. That's the basic principle of bubble sort. Moving on to the next pass, we repeat this process, but this time, we leave out the last element since it's already sorted. Again, we bubble up the next largest number, say 5, to the second last position. We continue this process for each pass through the entire array until the array is sorted. And voila, our array is now sorted. Now let's take a look at the pseudo code for bubble sort. Here's the actual code in. You can pause the video to take a closer look or check out the code in the video description. Before we wrap up, it's important to note that the time complexity of bubble sort is O(n)². While it's not the most efficient sorting algorithm for larger data sets, it's great for learning purposes. Before diving into the code, let's first understand the basic idea behind bubble sort, and then we'll use graphics to aid our understanding. Imagine we have an array of numbers to sort. We have a simple array of integers. Now, let's dive into what's the basic idea behind bubble sort, and then we'll bring in graphics to assist us. Picture a line of people, all of different heights. The bubble sort algorithm's job is to repeatedly swap two people if they're in the wrong order. This process bubbles the tallest person to the end of the line with each pass. Think of it like a dance where everyone is trying to get to their right spot. We start with the first pass. We compare the first two people and swap them if necessary. We continue this process for the entire line. This is where our graphics come in handy. Visualize how the tallest person in the line, let's say she's 7 feet tall, bubbles up to the end of the line. That's the basic principle of bubble sort. Next, in the second pass, we repeat this process, but we leave out the person at the end because she's already sorted. Again, we bubble up the next tallest person, who's maybe 5 feet tall, to the second last place. It's like a dance again, but with one less participant. We continue this process for each pass through the entire line until the line is sorted. And there you have it. The line is now sorted. It's like everyone has found their right spot in the dance. Now, let's take a look at the pseudocode for bubble sort. This is a simplified version of the code that gives us a high-level view of how the algorithm works. It's like the choreography for our sorting dance. Here's the actual code in. You can pause the video to take a closer look or check out the code in the video description. Before we wrap up, it's important to note that the time complexity of bubble sort is O(n)². It's not the most efficient sorting algorithm for large datasets, but it's good for learning purposes. See how the largest member, 7, becomes a bubble at the end. That's the basic principle of bubble sort. Opening. We start with the first pass. We compare the first two members and swap them if necessary. We continue this process for the entire array. As we venture into the heart of the bubble sort algorithm, it's important to remember that this algorithm is all about comparison and swapping. So, how does this play out? Let's visualize it. Think of the array as a racetrack. Each element is a racer, and the goal is to get the highest number or the heaviest racer to the very end of the track. On the first pass, we look at the first two racers or numbers. If the first racer is heavier than the second, we make them swap places. This way, the heavier racer moves one step closer to the end. We repeat this process, comparing each pair of racers all the way down the track. By the time we reach the end, the heaviest racer has bubbled its way to the finish line. This is why we call it bubble sort. The largest element bubbles up to the top, or rather, the end of the array. Now, you might be thinking, great, we've sorted the array, but hold your horses. We've only completed the first pass. The heaviest racer may be at the end, but what about the rest? They're still jumbled up. This is where the second pass comes in. On the second pass, we do the same thing, compare and swap. But this time, we ignore the last racer because we know they're already in the right place. Again, the heaviest of the remaining racers bubbles its way to the end just before the racer from the first pass. As we continue this process, each pass leaves the heaviest racers of the remaining group at the end, and the lighter ones gradually move towards the start until all the racers are lined up in order from lightest to heaviest. It's crucial to understand that bubble sort is not a one-pass process. It's iterative, which means it repeats a process until a condition is met, in this case, a fully sorted array. One way to visualize bubble sort is to imagine the array as a series of bars, with the length of each bar representing the size of the element. As the algorithm runs, you'll see the longer bars gradually move to the right, while the shorter ones move to the left. Let's talk about efficiency. Bubble sort is not the most efficient sorting algorithm out there. In the worst-case scenario, where the array is in reverse order, bubble sort would need to make as many passes as there are elements in the array. This gives it a time complexity of O(n squared, where n is the number of elements. Despite its inefficiency with large datasets, bubble sort has its uses. It's simple to understand and implement, making it a good starting point for learning about sorting algorithms. It's also handy when dealing with small datasets or arrays that are nearly sorted. And there we have it. The array is now sorted. We've journeyed through the process of bubble sort, from the first pass to the final result. We've seen how this simple yet powerful algorithm can transform a jumbled array into a neatly sorted one. Remember, the beauty of algorithms lies not just in their ability to solve problems, but also in the way they approach these problems, breaking them down into smaller, manageable tasks. So keep exploring, keep learning, and let the power of algorithms guide your journey in the world of programming. Ending. And there we have it. The array is now sorted. Now, let's take a look at the pseudocode for bubble sort. This is a high-level representation of the algorithm, and it's written in a way that's easy to understand, regardless of your programming background. First, we start with an unsorted array of integers. Then, we loop over the array from the first element to the penultimate one. For each element, we compare it with the next one. If it's larger, we swap them. This process is repeated until we go through the whole array without having to make a swap. This whole process can be seen as bubbling up the largest element to its correct position in the array, hence the name bubble sort. The pseudocode for this process might look something like this. For I from 0 to n2, for j from 0 to ni2. After each iteration of the outer loop, the largest unsorted element is moved to its correct position, reducing the size of the unsorted part of the array by 1. Now, let's translate this pseudocode into actual code. In this example, we'll use Python, a popular and beginner-friendly language. Def bubble sort array. N =, len array for I in range, n. As you can see, the actual Python code closely follows the pseudocode. If you're using a different language, the syntax might vary, but the basic logic remains the same. Now, let's talk about time complexity. Time complexity is a measure of the amount of time an algorithm takes to run as a function of the size of the input to the program. In the case of bubble sort, the time complexity is O(n squared in the worst-case scenario, where n is the number of elements in the array. This happens when the array is reverse sorted, and we have to make the maximum number of swaps. In the best case scenario, where the array is already sorted, the time complexity is O(n). But this requires us to modify the algorithm to stop after a pass where no swaps were made. It's important to note that the time complexity of bubble sort is O(n squared). It's not the most efficient sorting algorithm for large datasets, but it's good for learning purposes. The simplicity of bubble sort makes it a great starting point for understanding how sorting algorithms work and how we can analyze their performance using the concept of time complexity. So that's bubble sort for you. Simple, right? We've gone over the basics of this sorting algorithm, visualized it in action, and even dived into its pseudocode and time complexity. It's a fundamental concept in computer science, often taught in the early stages of programming and algorithm courses. Bubble sort is a great starting point for understanding how sorting algorithms work. Its simplicity lies in its straightforward mechanism, comparing adjacent elements and swapping them if they are in the wrong order. This process continues until the entire array is sorted, with each pass bubbling the largest element to its correct position at the end of the array. However, despite its simplicity, bubble sort does have its limitations. For one, it's not the most efficient sorting algorithm out there, especially for larger data sets. Its time complexity is O(n squared, which means the time it takes to sort an array grows quadratically with the size of the array. This makes bubble sort less suitable for large-scale, real-world applications where efficiency is key. But don't let this deter you from exploring bubble sort, even if you don't use it in your future coding projects. Understanding it can help you grasp more complex sorting algorithms. It's all about building a foundation, and bubble sort is a solid brick in that foundation. So why not give it a try? Try implementing bubble sort in your preferred programming language. Experiment with it, play around with different data sets, and see how it performs. You can even challenge yourself by optimizing it or comparing its performance against other sorting algorithms. Remember that learning is all about experimentation. It's about trying, failing, and trying again. So don't be afraid to make mistakes or get stuck. That's part of the process. And when you do get stuck, don't hesitate to revisit this video or seek help from the community. Before we wrap up, we'd like to remind you that this video is part of a series where we explore different algorithms and data structures. So, if you want to continue expanding your programming knowledge, make sure to stay tuned for more. And that brings us to the end of our bubble sort journey. We hope you found this video helpful and enlightening. If you did, don't forget to hit the like button, subscribe, and ring the notification bell to stay updated on future videos. We have a lot more interesting and valuable content coming up, and we wouldn't want you to miss out. Thank you for joining us today on this learning adventure. Keep coding, keep exploring, and as always, stay unstoppable.